The Cafferty Group, technical service advisors with offices located in Nebraska, Iowa, Kansas, and Colorado, presents Refrigerant Charging Techniques. Refrigerant charging. For a partially charged system, what's the reason for the undercharge? Is it improper commissioning? System has been undercharged since day one? Is that a system leak? Check the service records. Check the system for leaks. Look at flare nut connections, service valve packing gland, or flooded evaporators. Use a leak detector and check the water for traces of refrigerant. On a flat system, why is the system flat? Is it a new startup? If it is, follow the manufacturer's published startup procedures. Is it an existing system? If so, is it a system leak? Check the service records. Check the system for leaks. Look at flare nut connections, service valve packing gland, and flooded evaporators. Use your leak detector and sniff the water for traces of refrigerant. In the event that you have a partially charged system, when do you decide to pull the charge and weigh in a new one, or keep the charge and top it off? When is it too much or not enough? What do I do? There are many types of systems with varying proper charge amounts. If a leak was discovered and repaired without the need for recovery, then how do you get the charge to the correct amount? There are quite a few methods that have been used. Let's look at a few. Myths and more. Who taught you how to charge a partially charged system? Here are a few methods that have been used over the years, common but faulty when used as single indicators. Line temperature, bubbles in the sight glass, gauge pressures, compressor amperage, superheat, subcooling, coil delta T's or temperature differences, and frost. Line temperatures. Faults. How's your sense of feel? On the discharge line, maximum skin temperature is 140 degrees. Is 140 degree discharge gas temperature okay? Never touch a discharge line. On the suction line, how cool is cool enough? Low temperature systems could freeze your skin. This would be a poor way of diagnosing system charge issues. Bubbles in the sight glass. What could cause that? What is the source of the bubbles? Is it non-condensables in the system? Excessive pressure drop caused by a pinched pipe, undersized pipe, or a restriction? Low subcooling, undercharged? Unloaded compressor. This is also a poor way of diagnosing problems by itself. Pressure. Faults. What affects pressure? Ambient temperature. Dirty condenser coil. Dirty evaporator coil. Dirty air filters. Wrong evaporator fan speed. Improper airflow through the condenser. Pressure alone is a poor way of diagnosing system problems. Amp draw. Faults. What affects amp draw? A cool or a hot day. Clean or dirty coils. Dirty filters. Motor bearings going bad. Low or high supply voltage. Evaporator load. What is the proper amp draw? Rated load amps, RLA, Full load amps, FLA. Amp draw alone is a poor way of diagnosing system problems. Calculate superheat. Faults. What affects superheat? System design. Capillary tube or orifice. Thermostatic or electronic expansion valve. Ambient temperature. Latent and sensible loads. Evaporator fan speed. Dirty air filters. All of these things can affect superheat. Superheat alone is a so-so way of diagnosing system problems. Calculate subcooling. Faults. What affects subcooling? How much subcooling is enough? Winter condition. Summer condition. Is the condenser clean? Expansion valve setting. Subcooling alone is a so-so way of diagnosing system problems. Delta T, or temperature difference, faults. What affects delta T? On the evaporator, it would be latent load, fan RPM, filter condition, and duct static. On the condenser side, it would be dirty condenser, recirculated airflow, fan RPM, water-cooled dirty tubes. Suction line frost. Faults. This is an older method used on small charge, low-temp capillary tube systems. This is not applicable on comfort cooling applications, and a poor way of diagnosing system problems. A partially charged system. If a leak was found and repaired, or the system was undercharged from day one, you have two options. Option 1, log the system while you're charging it. Use the manufacturer's charging charts and operating parameters if available. If not, then add refrigerant while logging the system and monitoring a combination of the previous methods: superheat, subcooling, evaporator delta T, condenser delta T, system pressures, amp draw. Liquid charge or vapor charge. Option number 2. Recover remaining refrigerant from the system. Weigh in proper charge amount following the manufacturer's guidelines. Option 2 should always be used when charging a variable frequency, variable capacity system such as a ductless split system. Vapor charging. Always add vapor through the suction line. Never charge liquid through a suction line. Record the amount charged. When charging in lower ambient temperatures, a cylinder heater may be needed. Liquid charging. Warning: there is a potential risk using this method. The technician should be very careful and pay close attention while using this method. Connect all system measuring instrumentation. Start the system and monitor for correct pressures and temperatures. If the system has liquid line access through a king valve, connect the refrigerant cylinder to the king valve. Close off the king valve to restrict the liquid line. Monitor the head pressure very closely. Since your gauges are attached to the service valves and you are monitoring pressure from there, the pressure should rise and then fall as the liquid line is emptied. Charge liquid refrigerant into the liquid line once the pressure in the system is less than the pressure in the refrigerant cylinder. Head pressure will rise as the compressor is pumping against the king valve restriction. Stop the refrigerant flow if the head pressure rises too high. Open the king valve and monitor the system. Repeat until the system is properly charged. Charging a system that is flat. Make sure that the system is leak-free. Remove gas and evacuate the system using proper evacuation methods. Weigh in the proper charge following the manufacturer's guidelines. Start the system and monitor the performance. This is the best method of charging. Monitor the operation. Feel. Amp draw. Subcooling. Bubbles in the sight glass. Delta T. Pressures. Superheat. Frost. And weigh in the charge. Thank you for joining us for Essential HVAC Principles, Refrigerant Charging Techniques. If you have any questions or need more information, please contact the Cafferty Group Technical Service Advisors at one of these 12 locations.